5, Jumbo 50, over.
Jumbo 50, Alex 35, go ahead.
Alex 35, Jumbo 50, estimating the ARCP at 1930 Zulu, flight level 330, rendezvous altitude 240, one receiver. Request you go standby on your beacon for positive identification.
Alex 35, standby.
Go operate, please.
Alex 35, operate.
I have positive radar contact at 200 nautical miles, 12 o'clock, over.
Jumbo 50 is a C5 en route to an in-flight refueling rendezvous with a KC-135 tanker.
Jumbo 50, Alex 35, are you ready to copy information, over?
Alex 35, Jumbo 50, go ahead, over.
Jumbo 50, Alex 35, refueling altitude, flight level 250, altimeter setting 2992, offload 50,000 pounds, refueling heading 131, inbound drift 4 right, weather is clear in the refueling area, one tanker, over.
In this mission, Alex 35 is a single tanker briefed to offload 50,000 pounds of fuel to the receiver, a single C5.
Alex 35, Jumbo 50 with additional rendezvous information, over.
Jumbo 50, Alex 35, go ahead.
Alex 35, Jumbo 50, inbound track 130, drift -3, true airspeed 380, turn range 17, offset 7. Request clearance and in refueling, Oklahoma City, direct Hobart, direct Altus, flight level 310, over.
The C5 navigator has determined the exact turn range and track offset separation from the KC-135 and C5 turn range chart. This information is based upon the receiver's true airspeed and wind drift correction. The ARCP, the Air Refueling Control Point, is established during flight planning. The tanker reaching this point will go into an orbit using a racetrack pattern to the left with 2-minute legs. The inbound heading will coincide with the C5's refueling track. If everything's on schedule, the tanker will reach this position and establish his orbit pattern just before the receiver C5 reaches its ARIP, the Air Refueling Initial Point. The tanker is flying toward the receiver at an altitude of 25,000 feet. At this time, the receiver will be at an altitude between 27 and 34,000 feet, if approaching the refueling track from a long-range cruise situation. At a distance of 80 nautical miles from the tanker's beacon, the C5 will begin its descent at 2,500 feet per minute.
Alex 35, Jumbo 50, 80 nautical miles, leaving flight level 330 for flight level 240.
Jumbo 50, Alex 35, roger.
At 70 miles, the C5 navigator notifies the tanker crew, at which time the tanker will turn to the reciprocal of the receiver's inbound track, if not already on that heading. At this time, the two aircraft will be flying toward each other at 14 nautical miles per minute. The tanker maintains this heading until time to turn into the refueling heading. The C5 navigator communicates with the tanker navigator at 10 nautical mile intervals, down to 30 nautical miles.
Alex 35, Jumbo 50, level at flight level 240, over.
Jumbo 50, Alex 35, roger.
Alex 35, Jumbo 50, 25 nautical miles, over.
Jumbo 50, Alex 35, roger.
Jumbo 50, Alex 35, tally ho at 11 o'clock, over.
Alex 35, Jumbo 50, roger.
The C5 will normally be flying at 280 knots calibrated. The tanker is approaching at 275 knots.
Range 24.
24.
The C5 at an altitude of 24,000 feet is now 1,000 feet below the tanker's altitude.
Range 23.
23.
Range 22.
22.
Range 21.
21.
Range 20.
20.
At the rear of the tanker, the boom operator is preparing for the refueling.
Range 19er.
19.
During offloading, the boom operator will speak directly with the pilot of the receiving aircraft.
Range 18.
18.
At the next mileage call, the tanker pilot will begin his 180-degree turn.
Range 17. Start turn now.
17, turning to 131.
During the turn, the tanker pilot will reduce speed to 255 knots. The tanker navigator will call halfway through the turn, important for receiver spacing. This is the most probable time for sighting the tanker.
Alex 35, Jumbo 50. Tally ho, 10 o'clock, over.
If calculations are correct, the turn with diminishing of speed will bring the tanker to a position directly ahead of the C5 and 1,000 feet above. The distance ahead should be 2 nautical miles. The tanker pilot, accustomed to turning ahead of aircraft not as imposing as the C5, may be led to believe the C5 is much closer than it really is.
Pilot navigator, 3 miles.
Alex 35, Jumbo 50, 3 miles, 280 knots, over. Jumbo 50, Alex 35, roger. Pre-contact checklist.
Radio contact. IFF. Set. Navigator's report. Check completed. Engineer's report. Check completed. Pre-contact check completed.
The tanker at this point should be 2 miles ahead, 1,000 feet higher, on track with the C5.
Pilot navigator, 2 miles.
Alex 35, Jumbo 50, 2 miles, 280 knots, over. Jumbo 50, Alex 35, roger. Indicating 255, heading 131, over. Alex 35, Jumbo 50, roger.
The C5 is overtaking the tanker at a difference rate of 25 knots. Approaching 1 mile, the pilot will slow to 270 knots, a difference of plus 15. The C5 will then start its climb toward the pre-contact position.
Pilot navigator, 1 mile.
Alex 35, Jumbo 50, 1 mile, 270 knots. Leaving flight level 240, over. Jumbo 50, Alex 35, roger.
The tanker is on autopilot and presents a smooth platform to the approaching C5. The boom is at a 30-degree angle with a 10-foot extension. Maximum extension is 18 feet. The receiver pilot uses the boom like a rifle sight on his approach, lining the tip of the boom with the nose of the tanker, climbing at about 30 degrees. Each pilot, from his position, should be aware of the position the tanker fills in his windshield. If this were a night mission, it would be the only visual reference he'd have at this distance.
Pilot navigator, 1/2 mile.
Alex 35, Jumbo 50, 1/2 mile, 265 knots, over. Jumbo 50, Alex 35, roger.
Jumbo 50, Alex 35, boom operator, radio check.
Alex 35, Jumbo 50, I rate you loud and clear, over.
Jumbo 50, Alex 35, you are loud and clear also.
C5 speed is now reduced to tanker speed plus 10. At the half-mile distance, pilots new to this mission may detect tanker movement for the first time. The tanker, on autopilot, is holding a steady platform. As the pilot attempts to compensate for C5 movements, there's a natural tendency to overcorrect. The pilot realizes that he's not directly behind the tanker and puts his airplane in a slight bank to make the correction. As he does this, his heading changes ever so slightly. Now his heading is different by 1 or 2 degrees from that of the tanker. If the pilot does not correct in the opposite direction, his diverging heading will continue to carry him through the tanker's path into a position on the other side of the tanker. This rolling movement, once established, becomes increasingly more difficult to correct. The momentum of the massive C5 causes the airplane to continue on its established path even after correction has been applied. These heavyweight characteristics will become even more pronounced with the addition of more fuel and cargo to the existing mass. Corrections must be made as soon as possible, and the pilot must learn to anticipate aircraft movement after the corrections have been applied. At about 300 feet, the towering T-tail of the C5 will encounter the jet wash from the tanker. This will cause some momentary instability. As the tail moves on up through the tanker-generated disturbance, the effect disappears. The jet wash is then above the C5 wing and below the T-tail. The C5 pilot will continue to move in toward the pre-contact position. From the boom operator's viewpoint, the C5, the world's largest aircraft, will appear to be much closer than it actually is. Since he's more familiar with refueling smaller aircraft, he may be more apprehensive as the C5 moves toward the pre-contact position. At this point, the C5 pilot should use small throttle movements. When he moves through the tanker's downwash, he may need to stabilize and retrim. The C5 pilot must move slowly and cautiously up to the pre-contact position, which is about 50 feet behind and 10 feet below the refueling position. The pilot holds this position until he has stabilized the aircraft.
Alex 35, Jumbo 50, stabilized.
Jumbo 50, you're clear to contact position. Alex 35 is ready.
Jumbo 50, ready.
Every pilot will learn to depend upon certain position references, depending on which work best for him. The underside of the KC-135 fuselage has a stripe down the center, which the pilot may use as an alignment reference side to side. The two rows of director lights on each side of the line come on to provide position references after the boom is engaged. However, the boom operator can manually control the red director lights to give a visual signal to the pilot. In a closing and close-up position, the pilot may use the small antenna as a reference point. If the tip of the antenna aligns with the second row of rivets, as it does here, the C5 is in near optimum position. When the receiver aircraft is 10 to 20 feet behind and slightly below the boom, the C5 forward movement will stop due to the bow wave effect if closure rates are less than 1 foot per second. At this point, the aerodynamic force created at the nose of the C5 is butted to the tail of the tanker. From this point, the pilot must move in very slowly. The bow wave tends to push the tanker's tail up and the C5's nose down, so each aircraft will have to trim to adjust. As the autopilot of the tanker corrects the trim wheel will make about 15 revolutions. If the C5 were to pull out quickly at this point, it would have a violent effect on the control of the tanker. It would go into a nose-up condition equivalent to a rate of climb of 2,000 feet per minute. In close, the boom is visible, and the pilot can clearly see the distinctive markings on the boom. At this point, the boom operator will hold the boom at about 10 feet extension, back from the optimum 12 feet. As the C5 moves in 2 feet below the tip of the boom, the boom operator then extends it down another 2 feet and the receptacle toggles engage. The fuel receptacle is about 8.5 feet behind the pilot.
Alex 35, contact. Latched.
Jumbo 50, contact.
Jumbo 50, Alex 35, you are receiving fuel.
Refueling speed is usually at 255 knots indicated airspeed. If different, the difference should be pre-established. Refueling airspeed should never exceed 265 knots. Bow wave effect above this would be more than trim could accommodate. The pilot director lights tell the pilot what to do. Go aft, go forward, go up, go down. Micro switches in the boom activate these lights. They activate the fore and aft lights when the boom telescopes as the aircraft moves in and out. Up and down lights activate when the boom raises and lowers as a result of aircraft elevation changes. The limits of the lights indicate the established limits of the boom. It's important that these limits are not exceeded, or a forced disconnect, possibly damage to the aircraft, might result. Holding the contact position is an exercise in concentration. There's a certain skill in holding the airplane there, but it's dependent upon seeing movement the moment it happens. The sooner the pilot notices a change, the sooner he can put in a correction, oftentimes just a fraction of an inch. The biggest problem is fore and aft movement. The tanker appears to get bigger or smaller, but the visual change is so minute that the C5 can move quite a bit before it's detected. The best reference point or points for this motion is out of the periphery, such as the position of an engine with respect to a windshield post. To maintain roll reference, the pilot will concentrate upon keeping wings parallel with the tanker's wings. Up-down motion can be spotted if the relationship between the antenna and row of rivets changes. Pilots will detect lateral motion if they're alert to movements in relation to the centerline stripe or of the director lights. The left row of director lights runs almost directly out from the pilot's position. The co-pilot, 4.5 feet to the right, sits in line with the right row of director lights. If the pilot does not concentrate on a point or points of reference, such as the antenna, the airplane may move 2 or 3 feet before the pilot recognizes there's movement. Interphone and airplane-to-airplane conversation should be to a minimum. Any distraction can affect the pilot's concentration, and he could miss an important call. Once this intense concentration on the detection of movement has been broken, the pilot must work harder to maintain position within the boom envelope. In addition to concentrating on relative movement, the pilot must be aware of the muscular pressures he's applying to the flight controls. The pilot can maintain a more precise position if he relaxes during the air refueling. For a pilot inexperienced in this operation, it can be an exhausting task. It's sometimes wise to break contact and relax while the co-pilot holds position behind the tanker. With experience, the workload on the pilot goes down. The C5 holds 318,000 pounds of fuel. The KC-135 can deliver about 100,000 pounds. It would take 3 tankers to fully load this giant. There are 2 kinds of disconnect, planned and inadvertent. For this mission, the planned disconnect will follow the delivery of 50,000 pounds of fuel.
Jumbo 50, Alex 35, you have your briefed offload. Disconnect now.
Jumbo 50, disconnect.
Alex 35, disconnect.
The receiver should remain in the contact position until certain that the boom nozzle is clear of the refueling receptacle. While the 2 aircraft are in contact, the throttles of the C5 are set in a certain position with slight push or pull to maintain control. As soon as the boom is disconnected, the plane will inch back with little or no throttle change if there was no forward movement at the time of disconnect. The C5 bow wave will lessen its push on the tail of the KC-135, and the tanker autopilot will be compensating and readjusting the trim. The withdrawal should be quite slow until the C5 has reached a point about 50 feet behind. At this point, the receiver will maneuver to a safe position to ensure clearance from the tanker while obtaining the tanker post-air refueling report.
Post-air refueling checklist.
Jumbo 50, Alex 35 with post-air refueling report, over.
Alex 35, Jumbo 50, go ahead.
Jumbo 50, offload 50,000 pounds, contact Fort Worth Center on 279.3, over.
Alex 35, Jumbo 50, roger.
In this mission, the planned disconnect was successfully accomplished, an event which will be the normal situation. However, the crew members involved should be aware at all times of any unsafe conditions that might develop and be prepared to call for an immediate breakaway. In another situation, it's possible that the tanker would be in an autopilot off operation. This will create a different effect on the stability of the tanker platform. For the receiver, it's more important than ever to move forward at a slow and steady rate. All tanker trimming is manual, and any change in bow wave pressures, for example, stopping at 20 feet and dropping back slightly, then moving forward at a different rate, will cause the tanker to move unpredictably. It's better if the tanker pilot can anticipate the receiver's movement and trim accordingly. The more stable the receiver is, the more stable will be the tanker. If the receiver moves slightly right, the tanker is forced to the right and makes a correction to the left just to remain in the proper position. Then the receiver corrects back left, which moves the tanker to the left. Since the tanker already has a correction applied, the receiver's movement amplifies the tanker's, and an out-of-phase situation develops. The C5 air refueling system is not complicated, and the reliability of components is high. It is possible, however, for a system malfunction to occur. If a situation develops that would jeopardize safety, crews should abort the attempt. Both crews must be alert to any event which would call for a breakaway.
Jumbo 50, slow your rate of closure. Back 4. Alex 35, breakaway, breakaway, breakaway.
The boom operator actuates his disconnect button, flashes the director lights, and moves the boom up and out of the way. The tanker pilot will move his throttles to get max power to climb out and direct his co-pilot to turn on the rotating beacon. The pilot will actuate his disconnect button, retard the throttles to idle, and establish a positive rate of descent using inboard thrust reversers if required. The co-pilot will actuate his disconnect button and maintain visual contact with the tanker. Crews will have to accomplish the air refueling procedure at night. Some pilots prefer these conditions. The degree of darkness can vary from a pitch-black night to a full moon reflecting on an undercast. At night, the pilot does not have the boom tip tanker nose reference. He will approach the tanker at first by setting its lights in position within the windshield frame and then climb right up to it. A light on each inboard engine illuminates the underside of the fuselage, so the receiver pilot will be able to see the antenna when he gets in close. 2 lights on the underside of the tanker illuminate the wings, which enables the pilot to use the same reference points on the engines as he'd use in daylight. The pilot can use the lights in peripheral vision to detect fore and aft movements. Vertigo is a possible problem under night conditions. The intense concentration can lead to a feeling that the aircraft is turning, diving, or climbing. Once in the contact position, the receiver pilot can concentrate on the same tanker references without looking directly at the receiver lights. As is true during daylight conditions, the pilot will detect initial relative movement earlier by referencing the UHF antenna or the forward part of the fuselage and not concentrating on the director lights. The tanker discharges 6,800 pounds of fuel per minute. It takes about 15 minutes to offload 100,000 pounds. The total process takes 35 to 40 minutes. The jumbo jet tankers of the future will be able to offload 3 times the amount of fuel as a KC-135 in the same time. In 1929, Major Carl Spaatz directed the first air-to-air sustained refueling mission. Progress in this technique has added to our air superiority by allowing aircraft to remain aloft for indefinite periods of time, limited only by the endurance of the crew. Now, for the first time, the Military Airlift Command has the capability to transport, non-stop, troops, tank cargo for military operations, or supplies for humanitarian missions to any point on the globe. C5 in-flight refueling has added a vital new dimension to the concept of strategic airlift operations.